Welcome to the DIY Honda Garage channel. Welcome to this presentation on the DTC P050D, which indicates a cold start idle speed problem in the Honda Accord models from 2017 to 2023. This diagnostic trouble code, or DTC, is related to the PGM-FI system, which stands for Programmed Fuel Injection. When this code is activated, it suggests that the engine is not maintaining the correct idle speed during cold starts. Idle speed must be managed effectively, especially in cold conditions, to ensure smooth engine operation. The specific issue could stem from various components related to air intake and sensor performance. Understanding these underlying factors better equips us for accurate diagnosis and repairs. The DTC P050D correlates directly with the PGM-FI, or Programmed Fuel Injection System, which is vital for managing fuel delivery and maintaining idle speed. Affected components include the air intake duct, which delivers air to the engine, the air cleaner housing that filters incoming air, and the MAF sensor or IAT sensor that measure airflow and temperature. These sensors and ducts are typically located in the engine compartment and are integral to the vehicle's air intake system. If any of these components have issues, such as blockages or poor connections, it could lead to an inability to maintain the correct idle speed, particularly during cold starts. Several possible causes can trigger the DTC P050D. Poor connections in the air intake duct or air cleaner housing might lead to improper airflow into the engine. Additionally, if there are blockages in these components, they can restrict airflow, worsening idle speed issues during cold starts. A dirty air cleaner element can also impede airflow, which is critical for the engine's performance. Each of these problems could prevent the engine from receiving sufficient air, ultimately affecting the idle speed control. It is crucial to address these potential issues systematically to ensure a thorough troubleshooting process. A vehicle experiencing the DTC P050D may exhibit several symptoms. The most noticeable is erratic idle speed, particularly immediately following a cold start. Drivers may notice that the engine struggles to maintain a steady idle, fluctuating instead. Poor cold start performance can also surface, as the vehicle may stall or take longer to start up when the engine is cold. Lastly, there is often an increase in emissions, as improper fuel and air mixture can lead to incomplete combustion. Recognizing these symptoms is essential for timely diagnosis and effective repair. The first troubleshooting step for DTC P050D involves turning the vehicle to the on mode, activating the ignition without starting the engine. It's essential at this stage to utilize the HDS, or Honda Diagnostics system, to check for any pending or confirmed DTCs. If there are any DTCs other than P050D indicated, one should follow the troubleshooting path specified for those codes. However, if P050D is the only code present, you will proceed to the next step. This initial check is crucial, as it gets us oriented toward any possible broader electrical issues that may be affecting the vehicle's entire performance. In the second troubleshooting step, a visual inspection of the air intake duct is crucial. You should check for any signs of poor connections or blockages that may restrict airflow into the engine. This duct is vital for delivering unfiltered air to the engine, and any restriction can severely impact idle speed. If the air intake duct is found to be clear and properly connected, you will move on to the next troubleshooting step. Conversely, if any issues are found, reconnecting, repairing, or replacing the duct as needed will be necessary. Proper airflow is essential for operational efficiency, especially during cold starts. The third troubleshooting step involves a visual check of the air cleaner housing. This component plays a critical role in filtering dust and particulates from the air before it enters the engine. During this inspection, you should look for any signs of poor connections or blockages that may impede airflow. If the air cleaner housing is found to be functioning properly, the troubleshooting will progress to the next step. However, if blockages or disconnections are observed, replacement of the air cleaner housing is warranted. Ensuring this component is in optimal condition is key for engine performance and compliance with emission standards. Step 4 requires checking the air cleaner element for dirt or debris, which could obstruct airflow and affect engine performance. A congested air cleaner element can significantly reduce engine efficiency, especially during cold starts, when optimal airflow is crucial. If the air cleaner element is found to be dirty, it should be replaced to ensure that the engine receives an adequate supply of clean air. Conversely, if it is not dirty, you will proceed to the next troubleshooting step. Maintaining a clean air cleaner element is vital for responsible vehicle maintenance and performance, as it directly impacts combustion efficiency. Step 5 involves verifying the problem under controlled conditions. Start by allowing the engine to cool down to 122 degrees Fahrenheit or 50 degrees Celsius or less. This temperature is important to replicate cold start conditions accurately and provides a valid baseline for testing. Once the engine has cooled, use the HDS to clear the P050D DTC, thereby resetting the system for a fresh assessment. Start the engine and allow it to idle for at least 10 seconds while observing the OBD status for DTC P050D. If the HDS indicates a failed status, you will proceed to Step 6. If it shows passed, it implies the system is functioning correctly under current conditions. The 6th troubleshooting step requires you to start the engine and hold the engine speed at 3,000 RPM without any load. Like having a continuously variable transmission, CVT, in park or neutral. Do this until the radiator fan engages, then allow the engine to return to idle. While the engine is steady at 2,500 RPM for 30 seconds, utilize the HDS to check the MAF sensor's parameters, specifically focusing on the mass airflow value, which should be between 4.1 to 5.7 grams per second, G second. If the current conditions match this threshold, the MAF sensor will be considered functional, and you can proceed to Step 7. If not, replacing the MAF sensor or IAT sensor 1 is necessary to resolve any airflow-related issues. In this last troubleshooting step, turn the vehicle to the off mode and allow the engine to cool to ambient temperature. Once cooled, note the ambient temperature and then turn the vehicle to the on mode again. Quickly check the value from IAT sensor 1 using the HDS, as this sensor measures the intake air temperature crucial for engine performance. You will then compare this value to the previously noted ambient temperature. If it differs by 5.4 degrees Fahrenheit or 3 degrees Celsius or more, it signifies a faulty sensor, necessitating the replacement of the MAF sensor or IAT sensor 1. If the IAT sensor appears functioning properly, further checks should be made for dirt, carbon, or damage in the throttle body. Cleaning or replacing these components may be required to restore proper idle performance. After completing all necessary repairs based on the previous troubleshooting steps, it is essential to conduct a final verification. This step ensures that all repairs have successfully addressed the DTC P050D issue. Confirm the effectiveness of the repairs by using the HDS to check for any present DTCs. A successful outcome would indicate no DTCs remaining, and further observing the engine's performance to ensure it runs smoothly. Monitoring how the engine idles during cold starts will also provide vital feedback on whether the issue has been fully resolved. This cycle of verification reinforces the quality and reliability of the repairs performed, ensuring optimal vehicle performance. While specific preventive maintenance steps are not detailed in the provided text, regular upkeep is essential for preventing DTC P050D from reforming. It's advisable to routinely check the air filter and replace it as needed to maintain proper airflow. Inspecting the entire intake and duct systems will help identify any potential blockages or weaknesses before they escalate into significant issues. Adhering to a consistent maintenance schedule not only prolongs the lifespan of these components, but also ensures the engine operates efficiently, thereby enhancing performance and reducing emissions. Proactive checks can save time and costs in the long run, promoting better vehicle reliability. In summary, the DTC P050D indicates a cold start idle speed problem requiring careful diagnostic evaluation. Troubleshooting should begin with a comprehensive check of air intake components and their connections to ensure proper airflow. The systematic steps outlined in this presentation guide you through the process of identifying the root cause effectively. Attention to both the MAF and IAT sensors is critical, as these components directly impact how the engine handles cold starts. With diligent follow-through on the troubleshooting steps, along with the implementation of preventive maintenance, you can effectively mitigate idle speed problems in the Honda Accord. Thank you for your attention, and I hope this information aids you in your repair endeavors. Please like and subscribe to the channel. See you next time.